3 hours later.
TritonEye is comprised of three main components: the back end, which runs on the Raspberry Pi to count the number of cars, the front end website, which communicates with the Raspberry Pi and gets the output, and the available spot algorithm, which takes the data from the Raspberry Pi and converts it to present the available spots on the website.
We count the number of cars by using an image processing algorithm running on Raspberry Pi with OpenCV. We first implemented a simple program that tracks moving boards in a video. Then we improved our algorithm. Our algorithm is consists of two parts. First one is object identification, and second one is object tracking. For the object identification, we applied background subtraction algorithm so that it can find where is the moving pixels in the video. And then we apply some of filters to remove small noises in the frame. Then we can eventually find where moving objects are. And in the object tracking algorithm, we implemented two ideas to handle different angles in camera. So first one is line-based counting. In line-based counting, we gave a reference line in the frame and then count where the car is going in or going out. And in the area-based algorithm, we define some of area of interest and then check which area is occupied or not, so we can eventually track the direction of the car as well as how many cars are crossing the area.
The Raspberry Pi sends data over to the server using the TCP/IP protocol. The Raspberry Pi, which is the client, sends this data to my laptop, which is currently the server, using this protocol. The Raspberry Pi collects data as ones and zeros. Ones represent the car moving towards the Raspberry Pi, and zero represents the car moving away from the Raspberry Pi. The Raspberry Pi collects these ones and zeros and sends them to the server. The server interprets these ones and zeros as parameters to the parking spot algorithm. The parking spot algorithm determines the number of spaces available using these ones and zeros. Once that is determined, the website then displays the number of spaces available to the user.
The available spot algorithm works by utilizing the location of the Raspberry Pi placement. The Raspberry Pis are placed on the hills between the floors, which allows them to tell us which way the cars are moving. If a Raspberry Pi, for example, sends a signal of a 1, it means the cars move from floor 1 to floor 2. The number of cars on each floor is stored in an array with the index corresponding to the floor number. Index 0 keeps the track of the total number of cars that are entering the parking lot. Once we know the total number of cars per floor, we then can subtract the total spots to show the available parking spots in the garage. We want to know the total car count so we can take an account for lag. For example, if there's only one spot left on the 3rd floor and a car enters on the 1st floor, we won't know that spot is taken until that car gets there. And say that car is on the 2nd floor and a car on the 1st floor decides to enter again. Then we should tell them that spot is taken. Essentially, we are trying to predict what spot the car is going to